Okay, so here's that problem that they gave you, and it was about a piece of cardboard that was 12 by 14 inches in size, and they said, what if you cut away a square from each corner that's X inches in length in order to form a box? So this is kind of the picture they gave you, but I went ahead and did that so you could see what that would look like. Let's say we had some rectangular piece and you measured a square out, and they're not exact squares, but they're close enough. This is what would be what left. And so what we're going to do is just fold up the corners here to create a box. And so once we do that, we don't have something flat, we have something three-dimensional. So we can talk about volume, which is length times width times height. So this is what this problem's really about. So if we, so the first question they ask you is, what are the restrictions on X? Okay, what value can X be? So X is a length, and it's how deep we're going to make our cut. Well, if we think about this, if we're going to cut in X inches this way and X inches this way, the most that we could cut would be, and still have a box, would be 7 inches, because it would meet in the middle. If we made it 7 inches and we cut 7 inches this way and 7 inches this way, there would be nothing left. We would have cut it all away. So X has to be, the restrictions on the value of X have to be less than half of this. It has to be less than 7 inches, and of course it has to be bigger than 0 inches, or else we wouldn't be cutting into the box. So this is the restriction on the value of X. And then they want you to come up with a formula for the volume. So if you can visualize, what I did here was fold up this side. This side's going to be left, but the part that's being folded up is just this region, because the little squares got cut away. So this length right here, which is kind of like this side of my box, would be 14, and I subtracted an X here, and I subtracted an X here, minus 2X. So that is the length. And the width was 12, but then I took away X, and I took away X. So this region right here, which is kind of this side of my box, would be 12 minus 2X. And then the height, which is this, is the height. That is how deep I cut, and so that is just going to be X. So the volume, which is length times width times height, in my case the length would be 14 minus 2X, times the width, which is 12 minus 2X, times the height, which is X. And so this is an expression for the volume of your box. Then they ask you to do something that I thought required a video, because they want you to find the max volume. Find what value of X, and maybe they said, and also the length and the width, or what dimensions they could even say. I'm not sure what they asked you in your problem, but what dimensions. They could just say what value of X, but what dimensions yield the max volume. And I looked, because this is not a quadratic. We're good at finding max and mins for parabolas, because we know how to find the vertex, but this is going to be a cubic. If you multiplied all this together, it'd be X to the third, and that's a little more involved. So I was like, how do they want these students to do that? And they want you to use your graphing calculator. So here we go. Here's my graphing calculator. So what I'm going to do is show you how to use it. If you need to enter some function, hit your Y equals button, and I'm going to clear off whatever I have. And then I want to enter my volume, which was X, and I'm not even multiplying it out, times 14 minus 2X times 12 minus 2X. And so if you see, this button right here is where I use my variable button. And I just always choose X. There's different choices, but I just always choose X. Okay. So I've entered x times 14 minus 2x times 12 minus 2x, and that's my volume, so I have that entered. Now I want to graph it. So if I think about the restrictions on x, I wanted my x to be just between 0 and 7. So I want to pick x and a y that would be reasonable. So if you go to your window, it's going to say, what x and y do you want? Well, I have something in there from some other time, so I don't want these numbers. I might go from 0 to 7. I'm going to go to 10 because I just want a little bit of margin. And this is the scale. I'm going to have it go by ones. And then I won't have a negative volume, so my y is the volume. And so the volume will not be negative, so I'll put 0, and then it'll be some positive. I don't expect it to be 8,000 cubic inches. I expect it to be smaller than that. And I don't know how much smaller, but maybe I'll just say 100 just to make sure I can get it on the screen. And that gives me an XY range that ought to graph my volume. So I'm going to graph it and see what happens. And what I can see is that I did not pick a volume, my Y big enough. So I'm going to go back to my window, and I'm going to say I need a bigger. So I'm going to say 200 just to make sure I can see it on the screen. Okay, and so that gives me my volume. So right here is the highest point, which is the maximum, and I'm interested in knowing the coordinates of that point, okay? And so if I look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7 is what I'm limited by. So from 0 to 7, the highest point is here. So this is the point I'm interested in. So how do I locate that point with my calculator? You hit the second button, and then you're going to hit the trace, but calc is what we're after. Second, calc. And it's going to have a menu of things. And so we use this to find different things, but right now I'm interested in the high point, which is the maximum, which is number 4. So I'm going to select 4. And so it's going to ask me, are you on the left side of this point? And I'm not. I'm on the right side of this point. So I'm going to use my arrow, and I'm going to go all the way to the left side. Are you left bound? And so I'm going to hit enter to answer, yes, I am. And then it's going to say, are you right bound? And I'm not, and I'm on the left side. So I'm going to use this arrow button to go over here to the right side. And then once I'm on the right side, I'm going to say, yes, I am. And then it's going to say, do you want me to guess this value? And I'm going to hit enter to say, yes, I do. And it's going to land where I wanted it to at the maximum. And right here it says the maximum occurs when x is 2.147. I'm going to round that to 2 places, 2.15. Oops. X is 2.15 and Y is 160 about 6. Y is 160.6. So I don't know what my math lab wants you to round this to. They might want it to the nearest tenth. If they wanted the nearest tenth, we would call this 2.2 inches. That's how far we should cut into our box. The resulting maximum volume would be 160.6 cubic inches. And if they wanted the length, well, the length, I said, was 14 minus 2 inches. I would plug 2.2 in for x and calculate 14 minus 2 times 2.2 to get the length. If they asked me for the width, I would say 12 minus 2 times 2.2 to get the width. But I think they might have just asked the value of x, and so this would be what it is. So I hope that helps a little bit.